In mathematics, we often go forward and backwards. You have learned how to differentiate a function. Well, we should also think about how to anti-differentiate a function. And that leads us to the topic today. We're going to look at the antiderivative. And it turns out any differentiable function will have an infinite number of antiderivatives. We'll begin with a precise definition to make this clearer. A function f of x is an antiderivative of f of x on an interval I, provided that the derivative of capital F of x is equal to lowercase f of x. Theorem. The family of antiderivatives is actually a consequence of the mean value theorem. Let capital F of x be any antiderivative of lowercase f of x. Then all the antiderivatives of lowercase f of x have the form capital F of x plus a constant, where c is an arbitrary constant and is from the set of real numbers. Recall that the derivative of the natural log of absolute value of x with respect to x is equal to 1 over x on this very specific domain. That means we have the following theorem. The family of antiderivatives for the reciprocal function 1 over x on this very specific domain is capital F of x equal to the natural log of the absolute value of x plus an arbitrary constant on the same very specific domain. We'll begin this backwards thinking process by finding some antiderivatives. Now we know how to go forwards, so it's best to check that our family of antiderivatives is actually valid with differentiation. So you could think about differentiation as going forwards and anti-differentiation as going backwards. I'll begin with the proper notation. We want our family of antiderivatives to be represented by capital F of x. Now we're going to make educated guesses on what the antiderivative is. So right now we're going to look at the antiderivative of each of these functions. Since they're only separated by an addition sign or subtraction sign, we could look at each function here separately and go ahead and add all the antiderivatives together. And notice all I'm doing is applying my basic knowledge of differentiation rules. And so these are actually just known facts. And that's all I'm doing here. I'm just stating the facts. Some facts are harder than others, but that's why we're going to check by differentiating. And finally, we want the family of antiderivatives, so we have to add an arbitrary constant. Let's check our work by making sure that our facts are correct. So I'm going to take the derivative of capital F of x with respect to x. This one here requires the chain rule. And we want to see if this matches our lowercase f of x. And so notice a lot of things here match as expected. I'm actually using our forward-thinking process of differentiation to check our answer. Looks like everything matches. And when it matches, you gain confidence in differentiation and anti-differentiation. Once you realize that you've checked your answer, go ahead and circle your family of antiderivatives. I should say encapsulate your family of antiderivatives. Why don't we look at another example here? Let's try to find the family of antiderivatives for this particular function. We'll use capital G of x. Oh, before I begin though, let's change lowercase g of x to something more familiar. And once again, we are just memorizing and putting our knowledge to basic differentiation rules. Looking for the family of antiderivatives. So we'll do this one function at a time. And we'll check our answer by differentiation. We're going to differentiate capital G of x with respect to x. And we're trying to match our lowercase g of x. And notice these are our basic differentiation rules. Let's see if this first term matches. Yes, it does. This does not match. We need to figure out what's missing there. There it goes. And notice everything else is matching up. Oop. So this is exactly why we need to check our answer with differentiation. I forgot to differentiate one of the terms. I need to differentiate, or I should say anti-differentiate. I need to anti-differentiate one of the terms. And that's much better. All my basic rules of differentiation do match, and that is our family of antiderivatives. Now, this is not quite a family. This is just a single antiderivative. And it did ask for a family, so I got to remember to put what? You got to remember to put an arbitrary constant at the end. Let's do that. There we go. And there is our infinite number of antiderivatives, and that is exactly why we call this a family of antiderivatives.